Good morning to all. Now I'm going to present about Apriori algorithm. It is one of the important algorithm in the data mining. It can be useful for market basket analysis. Many shop owners are keeping many kind of items. So if they know what kind of items are buying together by the customers very often means they can keep accordingly. It can increase the profit for the seller. For that, mostly it can be used. So it is called one of the important algorithm for market basket analysis. It can be useful for inventory management, recommendation system, and also for storage management layout optimization. Today we'll see what is Apriori algorithm, how it works, and one of the example to calculate frequent item set. Here the input is a transaction database maintained in a shop, and also we need minimum support. The minimum support is used for to calculate the frequency. For example, one shopkeeper may feel that 100 items bought together can be the frequent. In another simple shop, 2 or 3 items buying together can be the frequency. So based on the usage, different owners or shopkeepers can maintain different number as a support count. So this is called threshold or minimum support. Here the output is the frequently items bought together by the customers. So the input is the whole transaction database. It can be the database of single day or 1 year or long term, and minimum support is another important input. The output is all the frequent item sets part. Now we'll see the Apriori algorithm. In the Apriori algorithm, in every step, we have to scan the entire database. We have to create two items. One is CK, another one is LK. CK is candidate item set, L1 is frequency item set. So first step, we have to scan the entire transaction database, and we have to create one item set. One item set means here we have to count each and every data, and we have to list how many times it occurs. That is called one item set C1. Suppose we are having 10 different items in the entire database. We have to list 10 different data items, and we have to count how many times each and every item comes. And after that, we have to count, we have to match how many times each data item comes. For example, I am having bread, butter like that. How many times bread comes, how many times butter comes, like that I have to compare. If any value comes equal to and above minimum support means I can maintain. Otherwise, I have to remove. So when I have to remove, when any data comes less than minimum support means I have to remove the particular data from the list. So after removing, I will get the L1. So C1 is nothing but all the one item data set along with the count value. L1 means all the one item set which satisfies the minimum support. Now I calculated C1 and L1. So now I have to increase my K value. Initially my K value was 1. So I calculated one item set and one frequent item set. That means C1 and L1 respectively. Now my K value equal to 2 here. I came to the step 3, my K value equal to 2. Now based on the K, I have to calculate the C2 and L2. So how to calculate the C2? I have to combine LK minus 1. Initially I had one item set, all the individual item set. If I do the joining operation, I will get the K item set. So if I do L1 join L1 means I will get the combination of two item set. So in the two item set, I have to count how many times each combination occurs. If each combination occurs more than this my minimum support means I have to maintain. Otherwise, I have to prove. So if any combination of two item sets are coming 2 and above, that means minimum support and above means I have to maintain. Otherwise, I have to remove. So the prove property is like the remove property in the second step. So again, I have to scan the entire database. I have to create the CK. Again, I have to check all the CK values with LK. What is LK? If any value that comes more than minimum support and above means I have to maintain, otherwise I have to prove. So now my LK is ready. Then again I have to increase my K value. Again I have to do the join operation. Again I have to calculate the CK like this. I have to increase every time, I have to increment the K value. I have to repeatedly do the operations until whenever the LK is empty. So when LK will be empty, we are having join operation, we are having combination of item set, but the combination of item sets does not satisfy with the minimum support I have to prove. So whenever LK is empty means in further that the minimum support value is not reached. That particular combination of data items are not frequent. So at that stage, I have to stop. So finally, I have to list the items. Here L1 represents item set 1, which is having minimum support. That means minimum frequency level. L2 means combination of 2 items which supports minimum support. L3 means combination of 3 items which supports minimum support. So like that, I have to count. So whenever LK becomes empty, I have to stop this algorithm. Here we have a simple example which contains a transaction database. In this transaction database, it is given as a tabular column. It contains transaction ID and items purchased for each transaction ID. Here transaction ID 1, 2, 3, 4 are given. In the first transaction, one customer bought rice and egg together. In the second transaction, rice and tea are bought together. In third transaction, rice, egg and coke are bought together. In the fourth transaction, egg and coke are bought together. So according to these records, we have to apply the Apriori algorithm to calculate the frequent item sets. Here the minimum support is given as 2. So every time we have to calculate the candidate item set and frequent item set based on the minimum support count as 2. Frequently item set. Now we will apply the Apriori algorithm for this example, which contains 4 transaction ID. Here we are having items rice, egg, tea and coke. There are 4 items are coming again and again. So first we will count the items for C1. As the step 1, we have to calculate for candidate item set 1. So we are having 4 items. So first we will list the item rice, then second item egg, then third item tea, then fourth item coke. So these are the 4 items available. So as we are calculating the C1, we have to take only one item combination. So rice occurs in the transaction 1, transaction 2, transaction 3. So totally it occurs 3 times. Then egg. Egg occurs in the transaction 1. In transaction 2, it's not available. In transaction 3, available. In transaction 4, it's available. So egg comes as 3 times. Then tea. Tea is available only in the transaction 2. So it occurs only one item. Then coke. Coke came in the transaction 3 and transaction 4. So frequency is 2 times. So now based on that we have to calculate the frequent item set 1. So we know our minimum support is 2. So if any item comes 2 and above means we can maintain, otherwise we have to cut. So here rice comes 3 times above 2, egg comes more than 2 times, tea it came only 1 time, so we have to cut it because occurrence is 1, it is less than the minimum support. And coke occurs 2 times, it exactly matches with the support, so we can keep. So L1 contains only 3 items. Rice, because it occurred 3 times. Egg, it occurred 3 times. Coke, it occurred exactly 2 times. So because of that, my L1 contains only 3 items. Rice, egg and coke. My C1 contains 4 items, combination of all the 1 item set. But after checking with the minimum support, my L1 contains only 3 items. Then based on this, I have to make a combination of L1 cross L1. L1 cross L1 means that will give the C2. So I have to combine all this with all one time. So rice and egg, rice and coke, egg and coke, like that, all the combination. Now we have to form the candidate item set 2. So how to form the candidate item set 2? Already we are having L1. So by combining L1 join with L1, we will get the C2. So we should remember our min support should be 2. So now by combining L1 and L1, so here in L1, T is eliminated. Why? Because it came only one time. So by combining the remaining items, we are having 2 item combination. So rice, comma, egg, then rice, comma, coke, then coke, comma, egg. So these are the possible combinations. Now we have to count how many times it occurs. Rice and egg. This combination occurs in transaction 1 and the transaction 2. So it occurs 2 times. Rice and coke. In the first transaction, this combination is not available. In the second transaction, also not available. In the third transaction, rice coke is available. In fourth transaction, it's not available. So rice coke available in only one time. Then we have to check the combination of coke and egg. Coke and egg is available in the transaction 3 and the transaction 4. So it also comes 2 times. So now we have to check with the minimum support. So our L2 we have to form, and L2 contains only the C2 items which satisfies the minimum support. So as per this example, our rice egg combination and coke egg combination is having 2 times occurrence. So I have to maintain rice and egg combination and coke and egg combination. So usually we will mention this kind of curly bracket in the L2. So now my L2 is over. Next we have to form the C3 and L3. So now we'll form the C3. How will we form the CL3? By joining of L2 comma L2. So when you are joining the L2 comma L2, so we are having only 3 values. Rice, egg, coke. And our minimum support is 2. So now we have to check whether these 3 items satisfies the minimum support. Rice, egg and coke. So this is available only in the transaction 3 and this occurrence is only one time. But we need minimum support 2. So this is not maximum. So that my L3 is empty. Why my L3 is empty? Even though I'm having 3 items in the C3, this does not satisfy my minimum support according to the given transactions. So my L3 is empty. So here I have to stop my calculation. So my algorithm ends with the L3. I'm not having any item is L3. My L3 is empty. Finally, I have to list the items which are frequent. So my L1 means one item set. What are the one item set available? Coke, rice, egg. So these are the frequent item set, one item set. Then my L2 is combination of 2 item set which are frequently available. Rice, comma, egg and egg, comma, coke. So these are the frequent item sets according to this algorithm. So my L3 is empty here. So there is no need to list the L3. Now we found the frequent items as per this example. So based on this, we can find the association. For example, we can also find if one person bought rice, there is a high chance of buying egg. If one person bought egg, there is a high chance of buying coke. So how to find this kind of association rule means we are having two additional parameters called support and confidence. Support means suppose if X is one item or set of items and Y is another set of items, we can find this is association between X and Y. Suppose as per this example, we found that rice and eggs are part together and coke and egg are part together. Then along with that, we are having two more parameters called support and confidence. Support is represented by if there we are having two items X and Y. We want to find whether two items are supportive means we have to count how many times X and Y occurs divided by total number of transaction in the entire database. Another thing is confidence. This can be measured by how many times X and Y occurred together in the transaction ID divided by how many times X alone comes in the database. So here also we are having minimum support and minimum confidence. If minimum support and minimum confidence are satisfied means we can say that this is a association rule as per this database.